Welcome back to Easy Learning. Today we are going to discuss the solutions of our exercise 2.2. But before that, let's discuss our your textbook exercise number 5 based on our cubic polynomial and the zeros of it. So we have studied the relationship between the zeros of a cubic polynomial and its coefficients, isn't it? In our last video we already discussed about the relationship between coefficients and the zeros of a cubic polynomial. What are the relations? Alpha plus beta plus gamma equals minus b by a, alpha beta plus beta gamma plus gamma alpha equals c by a, and alpha beta gamma equals minus d by a. These were the relations. So in your exercise number 5, that is example 5, one question is there to verify the relationship. I'll just read out the question. Verify that 3 minus 1 minus 1 by 3 are the zeros of the cubic polynomial p of x equals 3x cube minus 5x square minus 11x minus 3, and then verify the relationship between the zeros and the coefficients. This is the question. P of x is given, 3 zeros, alpha beta gamma is also given in your question. If this is not given, we need to solve this cubic polynomial and get the zeros of the polynomial. In the description box I have given the link of my video to solve a cubic polynomial. You can just see that video so that it will be more clear for you how to solve a cubic polynomial. If you have any doubt, you can just watch that video. Okay, so first thing is we have to write the general form of a cubic polynomial. What is the general form of a cubic polynomial? General form is ax cube plus bx square plus cx plus d. This is a general form of a cubic polynomial. For solving that, we are going to equate it with 0. So our p of x should be equal to 0. That is 3x cube minus 5x square minus 11x minus 3 equals 0. Okay, they have solved. Now question is solved and they have given the zeros of the polynomial. We know alpha, beta, gamma values. We just need to verify the results. That is, we just need to verify whether this relationship is correct or not. So here a equals 3, b equals minus 5, c equals minus 11 and d equals minus 3. Okay, then what will be alpha plus beta plus gamma? This minus b by a. We need to check whether left hand side is equals right hand side. LHS equals RHS. What is our alpha? We are given it is 3 plus minus 1 plus minus 1 by 3. Isn't it? 3 plus minus 1 plus minus 1 by 3, that is equal to minus b by a is minus b is minus 5. Minus 5 by 3. How much will be the answer? When we take the LCM, it will become 9 minus 3 minus 1 by 3 is equal to minus it will become plus 5 by 3. 9 minus 4 is 5 by 3 equals 5 by 3. That is LHS equals RHS. Hence it is verified that alpha plus beta plus gamma equals minus b by a. This is verified. Okay. What is the next relationship? Alpha beta plus beta gamma plus gamma alpha equals c by a or not. What is the alpha value? Alpha is 3. 3 into minus 1. 3 into minus 1 plus minus 1 into minus 1 by 3 plus minus 1 by 3 into 3 equals c is minus 11 by 3. This is minus 3 plus 1 by 3 minus 1. Then this will be minus 9 plus 1 minus 3 by 3 equals minus 11 by 3. This is 9, 10, 11, 12. 12 minus 1 minus 11 by 3 equals minus 11 by 3. That is LHS equals RHS. Hence verified. Isn't it? This relationship is also verified. Third relationship is alpha, beta, gamma equals minus d by a. Alpha is 3 into minus 1 into minus 1 by 3 equals minus d is minus 3 minus d is 3 by 3 by 3 1 3 into minus 1 minus 3 into 1 by 3 minus 1 into minus 1 is 1 equals 1, that is LHS equals RHS, hence verified. Okay, this is how you have to solve this question. Clear? Okay, now let's move on to our exercise 2.2. First question is to find the zeros of the polynomial and check the relationship between coefficients and the zeros of the polynomial. First question is x square minus 2x minus 8. So what we have to write? The first thing what you have to write is p of x equals x square minus 2x minus 8. Okay, we need to solve this, so we are going to equate it with 0. X square minus 2x minus 8 equals 0. A equals what? A equals 1, b equals minus 2 and c equals minus 8. Standard form is ax square minus bx plus c equals 0. This is a quadratic polynomial and you know it very clearly how to solve a quadratic polynomial. Okay, x square minus 2x minus 8. So we need to get product 8, sum 2. What are the numbers? When we add, we should get 2, and when we multiply, we should get 8. 4 and 2. How? X square. We need to get minus 8 as the product and minus 2 as the sum, right? That means minus 4x plus 2x minus 8 equals 0. Minus 4 into minus 2 is minus 8, right? Minus 4 plus minus 2 is minus 2, right? Then it will take x as a common factor, that means x minus 4 plus here x minus 4 and here we will take 2, x minus 4 equals 0. That is x plus 2 into x minus 4 equals 0, x equals minus 2, x equals 4. So we got the two values of x at which our p of x will become 0. That is x equals minus 2 and x equals 4. That means x equals minus 2 and x equals 4 are the zeros of this polynomial, or alpha equals minus 2 and beta equals 4. Is this clear? Okay. Next step is we need to check the relationship between the zeros of the polynomial and coefficient. We know sum of zeros of the polynomial alpha plus beta equals minus b by a and product is c by a. So first thing is we will check whether alpha plus beta equals minus b by a or not. Okay, alpha is minus 2 plus 4 equals, what is minus b? B is minus 2. Then minus b will be 2 by 1. Minus 2 plus 4 is 2 equals 2. That is LHS equals RHS. So this is verified. Okay. Next is alpha beta equals c by a. Alpha beta is minus 2 into 4 equals c is minus 8. A is 1. Minus 4 into minus 2 is minus 8 equals minus 8. That is LHS equals RHS. So this is also verified. This is very easy. Only two things you have to remember in this. You need to know how to solve a quadratic polynomial and you must remember the relationship between zeros of a polynomial and their coefficients. These are the two things you need to remember in this. Rest of the things is very easy. If you are not making a careless mistake, then 100% sure you will get 100% mark. Okay. Next question is 6 x square minus 3 minus 7x. Same question only, very easy to solve. First thing is, when you get any question, first you must write it in the general form. So how you will write? P of x equals 6x square minus 7x minus 3. Okay, here a equals 6, b equals minus 7, c equals minus 3. Then 6x square minus 7x minus 3 equals 0. Okay, we are going to solve the polynomial, so we will equate it with 0. Next, this is a quadratic polynomial and you know how to solve. The product must be 6 into 3, 18, and the sum must be 7. Okay, 18 and 7. Then think about the two numbers, 9 and 2. 9 into 2 is 18 and 9 minus 2 is 7. Okay, then 6x square minus 9x plus 2x minus 3 equals 0. Minus 9 plus 2 is minus 7. 9 into 2 is 18. Then we will take 3x as a common from these two. Then this will become x minus 3 plus here, sorry, 2x minus 3 plus 2x minus 3 equals 0. 3x plus 1 into 2x minus 3 equals 0. Okay, then 3x plus 1 equals 0 and 2x minus 3 is also equal to 0. Then this will become 3x equals minus 1 or x equals minus 1 by 3. Here 2x equals 3 and x equals 3 by 2. So these are the two values of x, or these are the zeros of this polynomial, or in other words they will say these are our alpha and beta values. Alpha equals minus 1 by 3 and beta equals 3 by 2. Okay, next step is what? We are going to check the relationship alpha plus beta. Alpha plus beta equals minus b by a. Minus 1 by 3 plus 3 by 2 equals minus b is minus of minus 7. Minus of minus 7 is plus 7 by 6. Okay, then what is the answer? 3 and 2. 6 is the LCM. Then this will become minus 2 plus 9 equals 7 by 6. This is equal to 7 by 6 equals 7 by 6. That means LHS equals RHS. This is verified. Is it clear? Then next is alpha beta equals C by A. Alpha beta is minus 1 by 3 into 3 by 2 equals C is what? Minus 3 by 6. Minus 3 by 6. This is minus 1 by 2. This is also minus 1 by 2. That is LHS equals RHS. So this is also verified. Okay, this is clear. It's very easy to solve these type of problems. Let's do our next problem. Next problem is 4u square plus 8u. So what is our first step? We will write it as p of x equals 4u square plus 8u. 4u square plus 8u. That is a equals 4 and b equals 8. Okay, next step is we are going to equate it with 0. 4u square plus 8u equals 0. I am going to take the common factor 4. Then this will become u square plus this will be u square plus 2u equals 0. Okay, then 4 into u square plus 2u. This is not in the form of a quadratic polynomial. So what I am going to do, I am going to add and subtract 1 from this. Why I'm doing like this? Because we know this is p of u. Okay, here the variable is not x, this variable is u, so don't make that mistake. I made that mistake without simply I wrote p of x, but here the variable is u, so we have to write p of u. 4 into u square plus 2u plus, because we know that a square plus 2ab plus b square is a plus b the whole square. We have studied that identity. So in order to get that, I just added and subtracted 1. Plus 1 minus 1 is 0. So instead of that, I just write it like that. Then what we are going to do, this is 4 into u square plus 2u plus 1 minus 4. Okay, I multiplied this 4 with minus 1 and it made minus 4, and this is 4 into u square plus 2u plus 1 minus 4 equals 0. That is u into u plus 1 the whole square minus 4 equals 0. I am going to take this 4 to the other side, that is 4 into u plus 1 the whole square equals 4. Here also 4, here also 4. I will cancel these 4, then it will become u plus 1 the whole square equals 1. Any doubt? Is it clear? Here I have one 4 and I have shifted this 4 to the right hand side. Then I can cancel this 4 and this 4, then it made 1, or 4 divided by 4 it will become 1. U plus 1 the whole square equals 1. That means u plus 1 the whole square equals 1. That means u plus 1, that means u plus 1 equals to 1 or u plus 1 equals minus 1. Plus or minus 1. Okay. Square, when we are squaring plus 1, we will get 1. When we are squaring minus 1 also we will get 1. So u plus 1 the whole square is 1. That means u plus 1 is 1 or u plus 1 equals minus 1. If u plus 1 equals to 1, then u equals 1 minus 1 is 0. U plus 1 equals to minus 1, then u equals minus 1 minus 1 is minus 2. Right? So these are the two values of u at which our polynomial p of u will become 0. So this is our alpha. Alpha equals 0 and beta equals minus 2. Alpha equals 0 and beta equals minus 2. Then we will directly substitute in our relation alpha plus beta. Alpha plus beta equals minus b by a. Alpha plus beta equals minus b by a, that is 0 plus minus 2 equals minus b. Minus b is minus 8 by 4. That is minus 2 equals minus 2. LHS equals RHS. It is verified. The next is alpha beta equals c by alpha beta equals c by a. Alpha beta means 0 into minus 2 is 0 equals c is, what is the value of c? C equals 0, right? What is the general form? General form is ax square plus bx plus c. Right? This is the general form of a quadratic polynomial. Here the value of c is 0. So c by a is also 0. LHS equals RHS. So it is also verified. Is it clear? Our next problem is t square minus 15 equals 0. How to solve this? T square minus 15 equals 0. That means t square equals 15. Okay. When you get this type of problem, don't try to make it as a quadratic polynomial or don't try to substitute it with zeros and all. Just do t square equals 15. Then t will be what? Plus or minus root 15. It's very simple, isn't it? T will be plus or minus root 15. So what are the values of t here? Values of t is t equals plus root 15. Another values t equals minus root 15. These are the two values of t at which our polynomial will become 0. This is our p of t. P of t. This is a p of t equals t square minus 15 is equal to 0. T square equals 15. T equals plus or minus root 15. Then t equals plus root 15 and t equals minus root 15. Then direct substitution alpha plus beta equals minus b by a or not. What is a in this? A equals 1, B equals what? B equals 0 because we don't have a term with t. And C equals minus 15, isn't it? If you want to write, you have to write it in general form first. It is ax square plus bx plus c equals 0. But after doing so many problems, then it should be clear for you. You have to how to write ABC values. Without even looking at the general form, you must know how to write it. Okay? Alpha plus beta equals minus p by a. What is alpha and what is beta? Alpha is root 15. Beta is minus root 15. What is b? B is 0 by 1. Root 15 minus root 15 is 0. 0 equals 0. That is LHS equals RHS. Isn't it? This is verified. Next is alpha beta. Alpha beta equals C by A. Alpha beta means root 15 into minus root 15 equals C is 15 by 1. Root 15 C is minus 15, right? Minus 15. Root 15 into minus root 15 is minus 15. Minus 15 equals minus 15. LHS equals RHS. So it is also verified. Clear? Let's move on to the next section. That is question number 2 of exercise 2.2. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. We are given sum and product of zeros of quadratic polynomial. We have to find the quadratic polynomial. Okay. First question is 1 by 4 and minus 1. That is alpha plus beta equals 1 by 4 and alpha beta equals minus 1. That is the first thing you have to understand. Read the question carefully. We are given the sum and product of zeros. This is not the values of alpha and beta. These are the values of sum of zeros and product of zeros. Okay? Don't confuse. Alpha plus beta equals 1 by 4 and alpha beta equals minus 1. What is the general form of a quadratic polynomial? P of x. P of x equals ax square plus bx plus c, where a not equal to 0. So the general form of a quadratic, when we are given the zeros, sum and product of zeros of a polynomial, how we will write the quadratic polynomial? It's very simple. Just listen very carefully. P of x equals k. K can be any real number, any number, k into x square minus alpha plus beta x plus alpha beta. This is a general form of a quadratic polynomial. Then how we will write? It is k into x square minus alpha plus beta is 1 by 4x plus alpha beta is minus 1. That is k into x square minus 1 by 4x minus 1 is the quadratic polynomial. Okay, how we will write? We will, this is general form, p of x equals k into any number. Before in our previous video we have done one problem of this type. How we have done? We have just find out the two values of alpha and beta and we just substituted. Each time we found that it is a multiple of k. When we are giving more values to alpha and beta, we will get multiples of k as the answer. So in general we write k into x square minus alpha plus beta into x plus alpha beta is a general form of a quadratic polynomial. This way also we can write. Okay, that is x square minus 1 by 4x minus 1 is the quadratic polynomial for this. Second question is alpha plus beta equals root 2 and alpha beta equals 1 by 3. Okay, then p of x will be what? P of x equals k into x square minus alpha plus beta x plus alpha beta. K into x square minus alpha plus beta is root 2x plus alpha beta is 1 by 3. This is the quadratic polynomial for these two, sum and product of zeros, root 2 and 1 by 3. Okay, it's very easy. Just need to remember this step. General form. Third question is sum is 0 and product is root 5. That means alpha plus beta equals 0. Alpha beta equals root 5. Then what will be our quadratic polynomial? P of x equals k into x square minus alpha plus beta x plus alpha beta. Okay. This is equal to k into x square minus alpha plus beta is 0. 0x plus root 5. That is equal to k into x square plus root 5. P of x equals k into x square plus root 5. Fourth question is alpha plus beta equals 1 and alpha beta also equals 1. Then P of x equals k into x square minus alpha plus beta x plus alpha beta, which is equal to k into x square minus 1x plus 1. It's equal to k into x square minus x plus 1. P of x. This is a way you have to find the quadratic polynomial when you are given sum and product of its zeros. Sometimes you will be given alpha and beta values. When you are given alpha and beta values, you know how to solve. If you are given alpha and beta values, you know alpha plus beta equals minus b by a and alpha beta equals e by a. In that way also you can come to the solution. Okay.